Hey guys, I'm going to work again on scale drawings today. Today we're going to talk about like how it actually happens. Yesterday we just made scaled up or scaled down versions of, rectangles and triangles and parallelograms and stuff. Today we're going to talk about like what scale drawings, like how they actually work and what they do. So make this your next title and your next free page, and then close it up and concentrate with me. So yesterday, here's like we just took a rectangle and said, these two rectangles are similar, or this rectangle has a scale factor of 3. So we made the side ratio, multiplied by 3, and found the lengths on the new rectangle. And so we just kind of made similar polygons, but they weren't connected to each other. Really, scale drawings are used for things like our Zoolander model we studied, and actually making a scale model, a thing where however big the model is has to do with however big the real school would be. So in a real scale drawing or a real scale model, they say in this model it's 3 feet wide or something, and 3 feet in the model represents 300 feet on the real building or something like that. So scale is used to make models and make drawings of things that are real. All right, so let's do an example like this one, say. So a landscape architect is designing a new park for his community. To design it, he's using a scale of 1 centimeter in his drawing, represents 10 yards for the actual park. Based on the drawing below, what will be the actual dimensions of the new park? So this makes a lot of sense, right? If you're designing a new park and the park's going to be really big, you can't make it's too much of a pain to make a design that's literally 100 yards long or something like that. So you use a ratio or a scale, and in this case we would write it like this. He says 1 centimeter in the drawing represents 10 yards for the actual park. So we'd kind of say 1 centimeter to 10 yards. That's how usually you see the scale factor or the scale ratio written out like that with our old, like the colon. You might see it in the other ratio forms, like 1 centimeter is 10 yards. But that's what it's going to do. So this park is drawn on 1 centimeter graph paper. So like these each show you 1 centimeter. So what will be the actual dimensions? So here he's saying 1 centimeter on the park is 10 yards in the actual park. So here is like 1 centimeter on his drawing. And so really that's 10 yards of the actual park. And this is another 1 centimeter in the drawing. So it's another 10 yards in the actual park. So if I look on the graph paper, it's 1, 2, 3, 4, 5, 6, 7, 8. So it's an 8 centimeter drawing that way, and a 1, 2, 3, 4, 5 centimeter drawing this way. And so I can use my ratio here, my scale factor, to find the actual park. If it's 8 centimeters in the drawing is how many yards in real life, that's equal to this ratio we're using here. 1 centimeter is 10 yards, right? And so here I'm kind of going times 10. So here I would go, I'm going times 8. So down but the 10, I would also go times 8 and say 1 centimeter is to 8 centimeters, as this makes 80 yards in the actual thing. So 8 centimeters is 80 yards in real life. And same thing with the 5, right? 5 centimeters in the drawing represents how many yards in real life? What's the same as that scale ratio? 1 centimeter is 10 yards. And so I can just easily do my scaling there, times 5. Times 5. 50 yards. So the actual dimensions of the park would be 80 yards by 50 yards. All right. So not terribly complicated, but it's very cool because this really happens. If you're going to design a building or a park or anything like that, a lot of times you just, in order to be able to draw it, you want to make it be the same ratio as the real park. You wouldn't want to have a real park, that was going to be this shape, but you make your drawing just like however you want, like that shape, and it doesn't, the ratio of the things don't line up, and so you can't really do it right. So that's why scale drawings are actually used. Okay? Open your notebook. Let's do one together. So no drawing this time. We can make our own. A satellite is 18 meters wide. A model of it was built with a scale of 1 centimeter to 3 meters. How wide is the model? So the actual satellite is 18 meters wide. Right? And we're going to draw a scaled down version of that. And our scale is that. So obviously the 3 meters is bigger than the centimeters, so that's the real one. So our scale ratio of model to actual is 1 centimeter represents 3 meters. 1 centimeter on the model represents 3 meters on the real thing. So we want to make an equivalent ratio to that. We know the actual satellite size is 18 meters. And we want to know how many centimeters wide that would be on the model. So that's just a ratio like we saw way back at the beginning of 6th grade in school, right? We would look here and say, well, this is times 6. So that's times 6. And a 6 centimeter wide model. That makes sense, right? If you were going to build a prototype, but you still want everything to be in proportion, your shrunk down version would be 6 centimeters wide. That's really small. Actually, I don't know how realistic that is. 6 centimeters is that's a very small model. That's actually about 6 centimeters. But hey, that's the answer to the problem. All right, guys, that's really all there is to it. That's how scale models work in real life. They just help people make larger or smaller versions of things, but keep everything in proportion so that as they make the model, it represents the real one pretty well. If either of those were difficult, please go back and watch them again. And otherwise, see you tomorrow.